Hi, this is Mrs. Vaughn here. So this video is for my Math 7 class for any students that were absent on the 25th of January. Okay, so let's go ahead and get into the review guide. So this is we're going to have a quiz tomorrow just on section 3.5, which is the least common multiple. And there's a couple of ways to figure it out, to calculate it. The first one is if your numbers are a little bit smaller. And then we use prime factorization when we work with larger numbers. So our first example here is they've asked us to list the first 10 non-zero multiples of 5 and then the first 10 non-zero multiples of 8. So, this means we don't include 5 times 0 because anything times 0 is 0. So this is 5 times 1, 5 times 2, 5 times 3, all the way up to 5 times 10. And then this one is 8 times 1, and so on until you get to 8 times 10. Okay, so with 5, it's 5. 5 times 2 is 10, 15, 20, 25, 30, 35, 40, and 45, 50. 8, 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. Okay, and then the last part of this is we want to identify what is the least common multiple of 5 and 8. So what is the smallest number that both 5 and 8 will divide evenly into? And when you look, you have 8. You know that any number that ends in 0 or 5 is divisible by 5. So look at the 8s. 8, 16, 24, 32, and then you have 40. We know that 5 divides into 40. And so that is the smallest number that both 5 and 8 divide into, which makes sense. It's 5 times 8. They don't have a lot in common. Now let's look at it with prime factorization. So prime factorization in the case of this section, where you find the least common multiple using prime factorization, they are giving you the factorization already. So they've already done the factor tree and determined, like for number 1, that the prime factorization of 80 is 2 to the 4th power times 5, and 192 is 2 to the 6th power times 3. So remember, with least common multiple, if you have a similar factor or a similar prime factor, in this case we have 2, you must always pick the one with the highest exponent. So we would include 2 to the 6th in the prime factorization of our least common multiple. Now, and then you also put every factor that exists in at least one of the numbers that you're comparing. So even though there's not a 5 in the prime factorization of 192, you would still make sure that you included that so that it gives you a number that 80 also divides evenly into. So when we do our least common multiple, that means this is 2 to the power of 6 times 3 times 5. You know that 3 times 5 is 15, and 2 to the power of 6, I think, is 64. I'm just going to go, no, there's no way. Actually, that would 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So maybe 64. So let's see. Pull up my calculator here. Yeah, I think that is 64. 1, 2, 3, 4, 5, 6. Yep. Okay. So this is 64 times 15, which is 960 once you do the math. So very big number. We have to go pretty far before we find a number that both 80 and 192 divide into. All right, number 2. Number 2 is 24 and 84. So again, we have a common prime factor. We have 2 to the 3rd and 2 squared. So we use the one with the larger exponent. They both have a 3, but both of them are the same. So just pick one. And then there's the 7, so we have to include that as well. So the least common multiple prime factorization is 2 to the 3rd, which is 8, times 3 times 7. So we know 3 times 7 is 21, 2 to the 3rd is 8, and 21 times 8 is 168. And you can always check it too, because 168, check and make sure, is that divisible by 24? Yes, 24 goes into it 7 times, and 84 goes into it 2 times. So, okay, moving on to number 3, it's the same thing. In this case, we're sharing common factors with all of them, but 72 has the prime factor of 2 to the third, which is the highest exponent, and 108 has 3 cubed, which is also the highest exponent. So those were the ones we would include with our least common multiple. 2 times 2 times 2 is 8. 3 times 3 times 3, the 3 times 3 is 9, and then 9 times 3 is 27. So now we have 8 times 27, which gives us 216. All right, 168 and 76. So same thing. We use the one with the higher exponent, so 2 to the third, and then there's a 3 and a 7 and a 19. So this one's going to be huge. So 2 to the third, to 2 cubed, 2 cubed times 3 times 7 times 19. Now, if you look up at number 2, you see that we already have the first part, 2 cubed times 3 times 7, we already know is 168. So this is 168 times 19. And when you do the math for that one, you find that it is 3,192. And that is 192. That is the smallest number that both 168 and 76 will divide evenly into. All right, number 5, we're comparing 18 and 30. So they both have a 2, so I'm just going to get the first one. They both have a 3, but 18 has 3 squared, so I need to take that one because it has the higher exponent. And then we also need this 5 from the 30. So 2 times 3 squared times 5 simplifies to 2 times 9 times 5. I'm going to do this one, I guess. That's 18 times 5, which I think it's 96. See, 18 times 5 is 90. So both 18 and 30 divides into 90 evenly. And 90 is the smallest number that they do so. Okay, so for number 6, again, we have 2 pretty big numbers, 120 and 135. Now, 120 has the 2 cubed, so we got to take that one. They both have a 3, but 135 has 3 cubed, so we have to take that one. And they both have a 5, so either one will do. We just need one. So 2 cubed times 3 cubed times 5. This is 8 times 27 times 5, so another big number. And so 27 times 8 is 216. And then when you multiply that times 5, you get 1,080. So that's the least common multiple of 120 and 135. All right, so let's find the least common multiple straight from scratch. So in this case, we're going to do our tree to find the prime factors. Then we're going to compare them to find the least common multiple. So first, what you want to do is go ahead and set up 48 and 54 ready for the prime factorization. So you can write them out one under the other and compare them to find out what factors go into your least common multiple. So if we do, some of these you might do yourself, but I think for these numbers, I'm definitely gonna do my tree. So 48, that's 2 goes into 4, 2 times 2 goes into 8, 4 times. So 2 times 24 is 48. 24 we know breaks down into 3 and 8. And these are both prime numbers, so we keep those. 2 and 4, and then 2 and 2. So the prime factorization of 48 is 1, 2, 3, 4 2s. So that's 2 to the power 4 times, and then we only had 1 3, so times 3. Now, if we look at 54, 54, 5 plus 4 is 9, so I know 3 divides into it. So 3 goes into 5 one time with 2 left over, and 3 goes into 24, 8. That's 3 times 18 is 54. This is another 3. 3 goes into 18 6 times, and then 2 times 3 is 6. So there's our prime factorization. It's 2, and then times 3 to the power of 3 Don't know why I did that. Let's see, go back. There we go. Okay, so now we can compare the prime factorizations. They both have a 2, but we have to use the one with the larger exponent. So that's 2 to the 4th. And they both have a 3, but we got to use the larger one. So that's 3 cubed. So 2 to the power 4 times 3 cubed. And 2 to the power 4 is 16. And 3 times 3 times 3 is 27. So 16 times 27 is 432. And that is our least common multiple. All right, so for 8, we have 3 numbers. And these are fairly small, so we should be able to pull our prime factorization without doing the tree. Just do it in your head. But you know that 9 is 3 times 3. Both of those are prime numbers, so that's 3 cubed. 12 is 3 times 4, which is 3 times 2 times 2, which is going to be 2 squared times 3. And then 15 is 3 times 5. So I'm going to mark through this since I duplicated it, so I don't confuse myself. And now I look at my factors. So I have 2, that's my smallest one, and I have only 1. So I'm going to take the 2 squared. There's a 3 in each one of these prime factorizations, but 9 has the 3 with the highest exponent. So I've got to include that one instead of the others. So that's 3 squared. And then there is a 5 down in 15. So I've got to make sure that gets added as well. So this is 4 times 9 times 5. 4 times 9 is 36. And 36 times 5 is 180. So that's our least common multiple. All right, so keep doing the same thing. Hopefully the process is starting to make a little bit of sense for you. So we have 56 and 60. Let's see, so 56, leave a spot for that. 60, I'm gonna do the tree for these. So 56, I know it's even, so I'm gonna start with a 2. 2 goes into 5 2 times, carry my 1, and 2 goes into 16, 8. So we have 28. Now 28 I know is 7 times 4. So I'm gonna go ahead and get that larger number out, and then the 4 breaks down into 2 2s. So we have 2 times 2 times 2, which is 2 to the power of 3, 2 cubed times 7. 60, I know it's 6 times 10. Those are not both prime numbers, but you can break the 6 down into a 2 and 3, and that makes a prime, and break the 10 down into a 2 and a 5. So we have 2 squared times 3 times 5. Okay, now we compare. Both of them have a prime factor of 2, but 56 has the higher exponent. So we're going, oops, I need to do that. So we're going to include that, 2 cubed. And then there's a 3 and a 5 and a 7. Got to include all of those. All right, so 2 cubed is 8. So that's 8 times 3 times 5 times 7, which equals 840. Okay, last one, number 4. Excuse me, I don't know why I said that. So tired. Number 10 is 4, 35, and 81. These are actually not that big. We might can do them in our head. You know, 4 is 2 times 2, so that's just a 2 cubed. 35 is 3 times 5, and 81 is 3. Okay, so 3 times 3 is 9, so that's 2. We could break down 81 just so I can show you. So this is 3. 3 goes into 8 2 times with 2 left over, and 3 goes into 21 7 times. So 3 times 27. So 3 goes into it again 9 times, and then 9 breaks down to 3 times 3. So 3 to the power 4 equals 81. So when we look at these, you see that 4 is the only one with a 2. So we've got to take that 2 squared. 35 and 81 both have a 3, but we've got to take the one with the higher exponent. So it's 3 to the power 4. And we have a 5 here that we also have to include. So 2 squared times 5 times 3 to the power 4. And so this is 4. So it's the whole 81. 4 times 5 times 81. And we can break down that break that down even more and say 20 times 81. And 20 times 81, no, hold on. 20 times 81 is 1,620. Super big number. All right. And that is the review guide. So if you had any trouble with any of those, then definitely go back and find some like it to practice with the homework. Send me an email. I'll be happy to work through some of the problems. I am sending home in your packet a workthrough of the homework so that you can see how I did it and then practice it on your own, checking your answers after you finish. Otherwise, that's it, and you will take the quiz on this tomorrow. Thanks so much. Talk to you guys later. Bye-bye.